Okay, permutations and combinations. Basically, we're wondering how many different ways can objects be selected or arranged. Now, the key phrase with permutations is they need to be arranged in a certain order. The order makes a difference. With combinations, the order is not important. So a group of Chris and Chad would be the same as Chad and Chris. However, if it was an arrangement, those would be two different possibilities. Here's the formula for figuring out permutations. For permutations, you take n factorial, how many total objects you have, over n minus r, where r is how many you're selecting. For combinations, your formula is somewhat similar, but it has an r factorial also on the bottom. Now, we also have permutations when we have repeated elements. When objects are being repeated, it's a slightly different formula. It's still n possibilities over a p factorial q factorial, assuming that there are so many p's available and q's available, and we'll be talking about that here in a bit. So 8 people enter the Best Picture contest. How many different ways can they award a blue, a red, and a green? Well, you got to decide, is this a situation when order makes a difference, or does it not make a difference? So if Todd got first place and Carmen got second place and Heather got third place, is that a different way of arranging it than Heather being first, Todd being second, and Carmen being last? Yes, it is. Since the order in which you select them or assign them does make a difference, it's then a permutation. Now, your permutation then, how many possibilities do you have to choose from? You have 8. How many are you selecting? You're selecting uno, dos, tres, 3. So, your formula then, your n correlates to 8, minus your r correlates to the 3, over 8 minus 3 on the bottom, which is a 5 factorial on the bottom and 8 factorial on the top. You could enter that in your calculator or work it out by hand. You would get 336. Now, if you worked it out by hand, you'd have to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over, and then 5 factorial. Now, when you do that, you would realize that this one drops to 1, that drops, that drops, that drops, and this drops, leaving you only with this right here in front. Let's take a look at the banana. How many different ways could we arrange the letters in banana? Well, how many different letters do we have available here? Well, we have 6 letters. But you notice some of these letters are being repeated. We have A being repeated 3 times. So we're going to put a 3 factorial on the bottom. But also n is being repeated twice, so you're going to have a 2 factorial on the bottom. So then you can type this into your calculator. Just make sure you'd put the whole denominator in parentheses, and you would get 60 different arrangements possible for the letters of banana. So we have 10 people competing in a swim race with 4 ribbons given. How many different ways can they be awarded? Well, when you're looking at first, second, third, and fourth place, the order in which you assign people there does make a difference, so it's a permutation. How many ways can this, how many people do we have to choose from? We have 10 to choose from. How many are we selecting? Blue, red, green, yellow, that's 4. So we use our formula and you get 5,040. How many different ways can algebra be arranged? Well, since we have some letters being repeated, it's permutation with repeated elements. You have a total of 7 letters. In this case, it's only A being repeated, and it's repeated twice, so it's 7 factorial over 2 factorial, or 2,520. Okay, 6 cards are drawn from a standard deck of cards. And there's 52 cards in a deck with 4 suits of 13 cards each. How many hands can consist of 2 hearts and 4 spades? Well, since you're just looking for any 2 hearts, the order in which they're selected wouldn't make a difference. So a jack followed by an ace would be the same as an ace followed by a jack. So that's a combination. Combination of 13, choose 2. 13 because there's 13 different hearts. 2 because you're selecting 2 hearts. Now we got to look at spades. Spades, same type of thing. It's a combination. The order in which they're assigned doesn't make a difference. You have a total of 13 spades to choose from, and you're selecting 4 spades, it says. Now, the fundamental counting principle that we talked about would say you'd have to multiply these top possibilities together. So you could type that into your calculator, times, and type this into your calculator. Yes, your calculator does do combinations and permutations. To have your calculator work this out, we'd have to go 13 in parentheses. Then we would go math, arrow over to prob, down to combinations. Then we would go 2, and then we'd have to do the next one. And so we would get that answer. Well, suppose we now have 6 friends at a get-together. 3 of them want to go pick up a movie. How many different ways could you get 3 people to go out of a group of 6? Well, whether Johnny goes first and Paula second, followed by Barbara, doesn't make a difference if it's Barbara, then Paula, then Johnny. So it's a combination, so order doesn't make a difference. You have a total of 6 to choose from. You have 3 that are going, and so then you work that out using your formula or your calculator, and you get 20. 13 cards are drawn from the standard deck of cards. How many different ways can 6 hearts and 7 diamonds be selected? Well, the order in which you select them from the deck of cards into a hand doesn't make a difference, so it's a combination. You have a total of 13 hearts to choose from, and you're selecting 6 of them. Diamonds, you have 13 diamonds to choose from, you're selecting 7 of them. And so then you could type it into your calculator just like I showed you on the last slide.